now you can see the solution. All right. So we want to solve this equation. Okay, so again, it's just like before. We want x all alone. Okay? We want to get x all alone. Okay? Okay, so how do we do that? Well, as you can see, what I did at least, I'm not, if you proceeded in a different way, that's fine. But I mean, I got the 3 out of there because I want x all alone. So we get negative 5x is negative 2. Okay, well, we don't want negative 5x, we just want x, right? So what do? We divide. And we get x is 2 over 5. Right, so we get negative 5x is negative 2. We divide by negative 5. This is what we get. Okay, that was fun. Okay, good. We had to, okay, so that's good. Let's look at some other examples. Okay, I was going to have people try these, for fun. So, but I guess I just let you guys try one. So let's keep going. Okay, so these are 2 examples I was going to have everyone. So let's keep going for fun. Okay, so for the first one, right here, this is where you want to simplify first, right? Remember, one of the things you can do is simplify either side of the equation. If you simplify the left side, you got to be careful because there is a negative here. This is what we get. So we have 5 times x, 5 times minus 3, minus 15, minus 6 times x, that's minus x. Notice here I'm distributing minus 6, not just 6. That's why we have a plus 24 here. So minus 6 times minus 4, that's plus 24. Okay, but again, let me say it again. Okay, so again, you want to distribute minus 6. And that should be easy to see for this one, minus 6x. But for the 4 here, minus 4, you want to get, that's why I get plus 24. Okay, you can't forget the negatives. That is, you can't forget the minus signs. Okay, so that's done. Now we can combine like terms, right? And what happens? We have 5x minus 6x minus 15 plus 24. And so we get minus x plus 9 is negative 5. That is what we get. And so that's really what I'm solving here. Okay. Okay, so what do? We want to get x all alone, right? So I subtract 9 from each side. We get negative x is negative 14. Okay, then we divide by negative 1 because we want x, not negative x. And we get 14. But notice how I'm showing all the steps. That's really what I want to see when you guys perform problems, like on quizzes and exams. I want to make sure everyone, understands what I'm teaching. So I want to make sure, so I want everyone to do all the steps. Okay. It's also so that if your answer somehow was wrong, like for some reason, if you did not write 14, you wrote something else by mistake, I can give you, almost all the credit if you show me your work. Okay? Partial credit, that is. Okay. So that's good. Okay. Are there any questions about this? I'll take that as a no. So that was one example. Here's another one. So here, this one's a little bit different, right? We have x minus 9 is 9 plus x. Okay, so what I did this was, although it's probably more work than necessary, but we can add 9 to both sides. We get x equals 18 plus x. Okay. Now, what do I do next? Well, you can probably see that you can subtract x from either side. and you get 0 is 18. Well, this doesn't make sense, right? So in other words, we got something that's false. Thus, there are no solutions. Or another way of saying this is the solution set is empty because 0 does not equal 18. You probably could have gotten this immediately if you subtracted x from both sides initially, because then you would have -9 equals 9, and that's also false. So just letting you know. But basically, we have an equation here that has no solutions. Okay. All right. Now, before we move on, there's some other vocabulary I have to present. Basically, the idea of multiples, and this didn't come out. That's all right. But basically, this should be hidden, but I guess it's okay for now. For any integer n, we can consider what's called its multiples, okay? The multiples of n. And those are just these numbers. Essentially, what you're doing is you're multiplying n by the non-negative integers, okay? Actually, you know what? Let me fix this quickly. You're multiplying n by the non-negative, oh, darn it. Let me just fix something quickly. The animation pane. I just want something hidden. Oh, whatever. You know what? Forget it. Let me just keep going. I was going to fix something, but I don't want to waste too much time, so let's just keep going. But that's what the multiples of n are. Okay. So I just threw in an example here. The example, for instance, if you look at the multiples of 3, you have 0, 3 times 1, which is 3, 3 times 2, which is 6, 3 times 3, which is 9, and so on and so forth. And now we can get to this new terminology, the least common multiple. If you have two non-zero integers, m and n, so they're both non-zero, the least common multiple, also denoted by LCM, is the smallest positive integer that's a multiple of m and n. So it's a positive integer, and it's the smallest multiple of m and n. So 0 cannot be the LCM. Okay? I mean, that's always going to be a common multiple, but it's not the least common multiple. Because by definition, the least common multiple has to be positive. Also, this definition generalizes to more than 2 non-zero integers. So if you had 3 or more, the definition would be the same. It's the smallest positive integer that's a multiple of the numbers. So I did an example here. I thought this would be hidden, the 8, but for some reason it wasn't. But anyway, if we want the least common multiple of 6 and 8, all we can really do is list the multiples. I mean, really, I guess we can ignore 0. So maybe I could have taken 0 out of the definition, but that's okay. So anyway, we can list them. We have 0. We have 6 times 1, which is 6. 6 times 2 is 12. 6 times 3 is 18, and so on. You can keep on going. Same thing with 8. You have 0, 8 times 1, 8 times 2. But hopefully you can see, again, we can cross out 0 because we really don't need it. But notice that the first positive entry in both lists is 24. So 24 would be the least common multiple of 6 and 8. I mean, there is another common multiple, right? We have 48, which is actually 6 times 8, but 24 is smaller and positive. That's the least common multiple. Okay, that's good. There are actually fancy ways to find the least common multiple, but those ways involve some more, not too advanced, but more advanced number theory. But for now, all we can do is list the common multiples. Okay. All right, so let's do some more examples. And of course, this should not be there. I thought this would be hidden. Oh well. Anyway, here's another example of 12 and 10. So here, right, we have 12. And so again, I didn't write 0 in because 0 can't be the least common multiple. So really, we can ignore that. So we have 12, 24, 36, 48, 60, and so on. And actually, you could stop at 60 because we know that if the last digit is 0, then 10 is a factor of it. In other words, it's a multiple of 10. So then if we were to list 10, we have 10 times 1, 10 times 2, 10 times 3, and so on. And we would see that 60 is the first positive common entry. So that's why 60 would be the least common multiple. I thought this would be hidden, this stuff here, but it's not. So, but I guess that's okay. But basically, we can use the least common multiple to solve these equations, which are still linear, but notice they have fractions here. And essentially what we're going to use the least common multiple to, we're going to use it to eliminate the denominators. Let me just stop the recording, then I'll pause the recording, then I'll continue.